on this second round of long division, let's look at a first one where the remainder is not 0. So I've got one up here, we did the math, and it turned out your remainder is 5, which is fine. Just got to know how to write our answer when your remainder is like a regular number, not 0. Grab your answer, x plus 3. Then we're going to add in the remainder, 5. We always put whatever your remainder is on the top, and then whatever your divisor is goes on the bottom. So whenever you get an answer where the remainder is something not 0, this is how you write it. All right, so there's one quick example, and then we've got 3 big, long, nasty ones in a row. Here it comes. All right, second example. M cubed plus 2m squared plus 9. So when you get the problem, it's going to look like this. You've got to start being ready to look for some holes that you have to fill. This is what I'm talking about. Here's a third power. Here's a second power, but there's no m to the first power. You're missing the m to the first power. You have to account for that. You've got to fill that spot. So let's set it up. We have m minus 3. We're going to write this in, m to the third minus 2m squared. The one that you're missing, you have to fill that spot with a 0, plus 0m minus 9. So be on the lookout for all these problems today. You got to fill those gaps. All right, let's start this guy. Lead off hitter, lead off hitter. So m to the third over m. Looks like you got 2 m's left, m squared. That's going up into your answer row up top. It's m to the second power. So go to your second powers. It goes in that column. Stay organized. Grab your m squared. It has to multiply times the divisor. We remember how this works. Hit it, hit it. M to the third minus 3m squared. So you built this. We're going to slide it in underneath. M to the third minus 3m squared. And we did it right. This and this are exactly the same. They cancel out. That's what we want. So subtract, subtract, negative 2 minus negative 3, negative 2 plus 3. That's just m squared. Now it's going to look a little crazy. We're dropping a 0 down. I like putting the letters in there just so I keep it organized. You know, m squared, m squared, m squared, m squared. Just m, just m. It helps keep things organized. All right, let's go round 2. Looks like this one's going to have 3 rounds. Grab your leadoff hitter, m squared. Over that leadoff hitter, m. 2 m's up top, 1 m on bottom. Looks like you got a single m left that's got to run up into our answers. And again, make sure you get them in the right columns. M to the thirds, nope. M squareds, nope. Just plain m's. So just a plain m. So here we go, m times m minus 3, hit it, hit it, m squared minus 3m. Take this, slide it over, m squared minus 3m. Now, it's a subtraction. We've got it. These cancel out. That's what we're trying to accomplish. Just be careful with 0 minus negative 3 becomes positive 3. Let's drop down our last one. Bringing in a negative 9. Okay, third round of it. Leadoff hitter, 3m. Leadoff hitter, just an m. Simplify it, 3m over m. I've just got a regular number to put in. So grab my 3. It's right there in my regular number spot. Here we go. Take that 3 times your divisor. Distribute. So the 3 times the m, the 3 times the 3 gives you the 9. You've built it. Oh, it canceled out. Look at that. 3m minus 9, that one canceled. So we don't have to write the fancy remainder on this. Looks like this guy right here, that's going to be our answer. So on this one, remainder is 0, we're okay. M squared plus m plus 3. So that's going to be suffice for our final answer. So there's your first of the nasty ones. We got a couple more left. Let's run another one. All right, 3. Okay, let's see here. So we've got 3x to the third plus 9x minus 14 divided by x minus 2. All right, before you even start these, you have to look for any missing spots, any gaps you got to fill. Here's x to the, oh, I see it already. X to the first, x to the third, boom. We do not have an x squared. So we found one hole we've got to fill right now. So account for the x squared. Let's set it up. X minus 2. 3x cubed, 0x squared, plus 9x minus 14. All right. So make sure you scour the whole problem, find those gaps to fill. Let's run it. Leadoff hitter, leadoff hitter. That's not a very good x minus 2. Let's make that a little easier to see. Whoops, 3x cubed over x. So it looks like you're going to have the 3 still left and 2x is still left, x squared. So we got to grab what's left over, the 3x squared. It's going top row. Going to put it in the column with the other x squareds. Grab your 3x squared. Let's multiply times the divisor. So he has to distribute through those parentheses. Becomes 3 x to the third minus 6 x squared. All right, we're grabbing it. We're putting it in. 3x to the third minus 6x squared. We have exactly what we need. This and this cancel each other out. Remember, this is subtraction, 0 minus negative 6. So that becomes positive 6x squared. Let's drop down the next one, plus 9x. All right, here we go. Lead off hitter, 6x squared. Lead off hitter, x. So I have a couple x's up top, I have 1x down the bottom, the 6 is still there, 1x left. This is going up, and again, I love how it's organized. X third, squared, 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 regular x. We've got 6 to the regular x. We're going to throw him in right there. All right, let's multiply it. 6x times x minus 2. Let's get the next layer going in. 6x squared minus 12x. So we're grabbing this one, 6x squared minus 12x. We're going to slide it over here, and we are doing well. Our 6x squared is going to cancel the other 6x squared. Feeling good about these guys canceling out. And now I've got 9 minus negative 12, 21x. All right, we might just have enough room when we drop this 14 down. See if we can fit something in here. Okay, one more round of this one. I'm having problems with that. What's my lead off? 21x and x. So 21x over x, when I clean that up, it's just a 21. So x squared, just plain x's, way over here is the numbers, plus 21. So now I have 21 times x minus 2, so 21x minus 42. Oh, brother. So I have built this. It's good with the 21 x's. Now I just got to work the 14, subtract, negative 14 minus negative 42, positive 28. Oh, my. So we have a remainder on this one, 28. I think you can barely see that. So I'm going to rewrite my answer. Here we go. I've got 3x squared plus 6x plus 21. So I take my top row, and my remainder is 28, and I put that over the divisor. And that's how you write your final answer. All right. You think this one was bad? Just wait. We're going to do something really scary. All right, now for something really scary. 4. Okay, one more. Here we go. 4th power plus 6x 3rd power plus 3x minus 1. This is 2x squared plus 1. Okay, so you know when you start these problems, you've got to really hunt and look for any missing spots, any missing exponents. So 4th power, 3rd power, first, there it is again. So the x squared is missing. Up top, you got to fill that 0. Check the bottom. On the bottom, here's x squared. The x to the 1st power is missing. So we're going to have to fill a 0 in the top and the bottom. This no good. This no good at all. All right, here we go. 2x squared plus 0x plus 1. I wonder if I can get this to even fit on here. 4x to the 4th plus 6x cubed plus there's my 0x squared plus 3x minus 1. Can you see it? I think you can still see that. All right. It is large and in charge. This is a big one. Same process. Just grab your leadoff hitter and grab your leadoff hitter. Clean it up. 4x to the 4th, 2x squared. 4 divided by 2 is 2. Looks like a couple x's left. 2x squared going up. So you know 2x squared is going up here somewhere. Like, well, where am I going to put it? I'm going to put it with the x squareds. So here's 2x squared in the x squared column. Grab 2x squared times 2x squared plus 0x plus 1. So now this 2x squared multiplies through the whole parentheses. 2 times 2, 4x to the 4th plus 0x cubed. 2x squared times 1 is 2x squared. So the 2 times the 0 gives me the 0. So I built all this, bringing it over, 4x to the 4th plus 0x cubed plus 2x squared. So we're still good. The 4x to the 4th and the 4x to the 4th knock each other out. They're gone. Remember, this is all subtracting now. 6 minus 0, so that's 6x cubed. Now that's minus 2x squared. All right, check your signs, make sure you're good. Bring down the 3x. All right, 3 rounds of this. That's 1 down. Okay, next round. Leadoff hitter, leadoff hitter. 6x cubed, 2x squared. 6x cubed, 2x squared. So 6 divided by 2 is 3. Looks like we have 1x left up top. So my 3x, he's coming over here. 4th power, 3rd power, over here with the x's. So plus 3x. So 3x with the x's, x squareds together, x cubes together. We're organized. Let's build another layer. 2x squared plus 0x plus 1. So it's going to multiply all the way across the parentheses. 6x cubed plus 0x squared plus 3x. All right, here's another row. Let's shoot it over here. 6x cubed plus 0x squared plus 3x. All right, we're doing good. We know those are going to cancel out. That's good. Subtract, subtract, subtract. Negative 2 minus 0. Uh-oh. 3x minus 3. Look at that. That completely cancels out. So I've just got a 0 representing that. All right. Zeros are everywhere. bring down the -1. Let's see if we can get this last layer to fit in there for us. Lead off hitter. 2x squared minus 2x squared. Looks like just a -1 is what we've got. All right, fourth powers, third powers, second powers, x's, -1. Hopefully you can see it on the end there. All right, a -1 is going times 2x squared plus 0x plus 1. So multiplying by a negative is going to change those signs. -2x squared, it doesn't really change anything with 0, but negative times positive gives me a -1. All right, my last layer, going to try to run that down there. Boom. Oh, look at this, guys. I would not have thought that. Do you see it? Gone, gone, gone. Remainder 0. They all cancel out. All right, so nothing fancy for our answer. Just grab the top shelf. 2x squared plus 3x minus 1. So didn't even have to write a remainder on that. All right, be on the lookout for those missing spots that you got to fill with zeros. They're everywhere on this assignment.